Okay, so Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Okay, so last time, there is one more question actually on volume that we haven't answered. But I think I better let you guys try to do that question first. Oh, hi Fatha. I better let you guys try to do that question first. Basically, it is almost similar to the last example that we did, except that the axis of rotation is different. Dia punya axis of rotation adalah Y. So sebelum ni X, yang last tu adalah axis of rotation dia adalah Y. So I leave that to you guys. So try to do that question and then let us check later on. Hari apa? Hari kuliah kita hari Selasa. So let us check the answer this coming Tuesday. Okay, so better start with a new chapter sebab macam fresh lagi kan malam ni kan. So better for us to start with a new chapter. And then this coming Tuesday, we're gonna finish chapter 2. And then this coming Thursday, we're gonna start with a new chapter, chapter 3. So hopefully we will be a little bit fast compared to the tutorial. The lecture lah. Lecture should be a bit fast compared to the tutorial. Okay, so this is chapter 2, the first order differential equation. So basically what do we have in chapter 2? Okay, so basically we're gonna learn the method how to solve the first order differential equation. So basically we have two methods to solve them. The first one is that we can either use separable variable, or the second one is that the differential equation using the integrating factor. So we're going to solve differential equation using integrating factor Vx. But that one is basically for a linear first order differential equation. So basically if we can separate them, then we're going to separate them. Otherwise, we're going to solve them using the integrating factor. Alright, basically for application, we have 4 types of application that we're going to learn during lecture. So the first one is the population growth model, and then radioactive decay, not delay, is supposed to be decay. So this is C actually, a C, decay model. And then the Newton's law of cooling, and then electric circuit. So we have 4 application of first order differential equations. Okay, so now basically the first one, you should be able to distinguish between the general and particular solution, and then we should be able to learn how to solve separable differential equation, and then we should learn how to solve the differential equation by using integrating factor. So today we're going to learn the method of solving differential equation, and then later on we're going to see some application on how to solve differential equation model. Next, a differential equation is an equation which involve a differential, which is the derivative. So that means we're going to solve the derivative. So the first example is, let's say, dy over dx equal to 2x. So we're going to make sure we find out what is the value of y equal to what. And then ds over dt equal to 2t square minus 5. And s in terms of t, what is that? And then y double prime plus 2y prime minus 5y equal to 4. So this is basically a differential equation as well, but the order is 2. So because we have the second derivative, so the order is 2. So we are not going to solve the third one. We only going to solve either the first or the second example. So kita takkan solve benda yang second order lah. Basically in our syllabus, everything is about the first order differential equation. So it should be something that is quite easy for us to integrate them. Okay, so how to solve differential equation to get the solution? Okay, so if let's say y is equal to x squared plus 3x minus 1, and then we get the differential equation dy over dx is equal to 2x plus 3. So this is what happened when we differentiate them. But basically, what do we have in chapter 2 is the derivative itself, dy over dx equal to 2x plus 3, and then we want to know how can we get the value of y. Of course, the opposite of differentiation is actually integration. So that means we need to integrate them in order to find out what is y. So that means we can actually relate with what we have learned in chapter 1 where we learn how to integrate those function. So yang ni dia macam application lagi kepada integration tu. Okay, next. Okay, so solve differential equation. So differential equation, when you solve them, you can get two types of solution. The first one is a general solution where it must contain an arbitrary constant c. So when you integrate them, you're going to add plus c at the back. Another one is something called a particular solution. So that means it contains a specific initial value. So they must give you, for example, what is the value of x and the value of y, so that when we write down the value of y, we no longer having anything with c. So dah tak ada c. So it's supposed to be some value. So mungkin tambah 2 ke, tambah 3 ke. But we don't have an arbitrary constant anymore. We don't have the C sebab kita dah ganti nilai kan, so C tu hilang. So that is why we call them a particular solution. General solution, very general, so that means we are supposed to give our answer together with the plus C. Particular solution, we need to substitute all those value in and then we need to make sure we get rid of the C. Okay, so separable differential equation can be written in the form. Okay, so for example, let's say you might have them in the form of px over qy. So dy over dx equal to px over qy. So this one, you might have something like dy over dx equal to x over y, or dy over dx equal to px times with qy. So we can easily separate the x and the y. So for example, is dy over dx equal to x multiplied with y. So we can easily separate the x and the y. So same thing over here. This is x, this is y. So we can easily separate the variable. Another one is that dy over dx equal to qy over px. So the example for this is dy over dx equal to y over x. Again, it should be quite easy for us to see how to separate the x and the y. Okay, so how to solve? Right. So the first one, in order to solve them, we need to separate the variable of x and y. So when you look at them, you should be able to see how to separate the variable of the x and the y. It should be x by the side of the x and y by the side of dy. Okay, so if let's say we have dx of dy over dx, then that means the x will go to the right hand side. So we are going to have dy equal to px over qy dx, but we cannot have y on the right hand side because this is dx. So only x is allowed on the right hand side. So qy will need to go to the left. So we are going to get qy dy equal to px dx. Okay, so for example, the second one, dy over dx equal to px qy. Again, if you have dx at the bottom, so bring them up to the right hand side. So over here, we are going to have dx. So check the variable on the right hand side. Everything else should be x because this is dx. But I do have something with y. So that means this one should go to the left. So we are going to get 1 over qy dy equal to px dx. So do make sure to separate the variable. Okay, so the third one, dy over dx is qy over px. So do remember, if you have dy over dx, those denominator need to go to the right hand side. So we are going to get something like dy equal to qy over px dx. But since this is dx, I cannot have qy on the right hand side. So all the y need to go to the left. Therefore, it will be something like 1 over qy dy equal to 1 over px dx. Okay, so always make sure that all the term with x need to be beside dx, and if we have dy, all the y need to be beside dy. So dia kena sebelah-sebelah lah. Kalau dx dengan x, kalau dy dengan y. Okay, and then what should we do next? We have to integrate both sides independently. So once you separate them, then you're going to integrate them independently. What do we mean by independently is that you're going to integrate on the left hand side. You're going to get what is the answer on the right hand side on the left hand side. And then you're going to find out what is the integration on the right hand side. So we're going to solve them one by one. So solve the left hand side until you get what is the value, what is y. And then solve the right hand side as well. Integrate kiri, integrate kanan. I think it will be quite easy if we can see the example later on, but for now, do make sure to separate the variable and then integrate both sides. And then you're going to get your solution, but be careful. Is it a general solution or a particular solution? If they didn't give you any value to substitute, it's supposed to be a general solution. If they give you some value to substitute, it's supposed to be a particular solution. Okay, next. Okay, so for example, dy over dx is equal to 2x. So you should be able to see we have the x in our denominator, so we should bring them up to the right hand side. So we are having dy equal to 2x dx. Okay, so how do we know we can easily integrate them? So basically on the right hand side, there is no more terms in terms of y. So that means we can easily integrate them. On the left hand side, I don't have anything with x. So this is okay. So integrate both sides. We are going to get y equal to x squared plus c. So since we do have something with a c, this is a general solution. Next, what do we mean by a particular solution? Okay, let's say the same question, dy over dx is equal to 2x, but we are given some condition over here. When x is equal to 1, y is equal to 2. So we have some value over there. Okay, so now integrate. You are going to get y equal to x squared plus c. And then, of course, you need to substitute what happened when x is equal to 1 and y equal to 2. What is the value of c? So substitute in. So when x is equal to 1, y equal to 2, we are going to get 2 is equal to 1 squared plus c. Therefore, c is actually equal to 1. So once you know the value of c, go back to y equal to x squared plus c and substitute the value of c in. Therefore, y is equal to x squared plus 1. So those are the difference between a general and particular solution. So for particular solution, they should give you some value to substitute. So that is the reason why we can easily call them as a particular solution. That is for a particular point. So no more c, and this one should be some constant. Okay, next. Let us go to the first example then. dy over dx is equal to negative x cubed over y squared. So basically, do check your denominator first. So we got dx, so I need to make sure I have dy equal to negative x cubed over y squared dx. So since this is dx, only x is allowed on the right hand side. So the top one, this is x, so this is fine. But I have something with y at the bottom, so I need to bring it to the left hand side. So it's supposed to be y squared dy equal to negative x cubed dx. So now once you separate them, then you can integrate them one by one. So integrate the left hand side, and then integrate the right hand side. Okay, so separate them, integrate. Okay, so integrating y squared dy. So this one basically you're going to use a power rule for them. So adding 1 to the power, divide by the new power. So it will become y cubed over 3 equal to, so on the right hand side, again a power rule for them. So adding 1 to the power, so negative x to the power of 4 over the new power 4 and then plus with c. So y cubed over 3 equal to negative x to the power of 4 over 4 plus c. So this is also known as a general solution. Why general? Because basically they didn't give us any particular solution, any particular value, so we don't have any particular solution for this. Doing good so far? Do make sure to separate them and then integrate them. Okay, next. Solve the differential equation dy over dx equal to x y minus 2 when y0 is equal to 5. So now you should see this y0 is equal to 5. So that means when we give our solution, it's supposed to be a particular solution. So why particular solution? Because we do have some value in y0 is equal to 5. So y0 equal to 5, it simply means that when x is equal to 0, y is equal to 5. Because when we write down y0, it simply means that this is y of x. So the x is 0, the y is 5. So when x equal to 0, y is equal to 5. Okay, so let's see here. dy over dx equal to x y minus 2. Let's see our denominator. I have dx. So that means let us bring dx to the right hand side first. So dy is equal to x, y minus 2 dx. So since dx is on the right hand side, only x is allowed on the right hand side. But I do have something with y. Over here, we got y minus 2, so I should bring it to the left hand side. So this is 1 minus y minus 2, 1 over y minus 2, dy equal to x dx. And then once I already make sure that all the y is already on the left, all the x is already on the right hand side, then we can integrate them. Okay, so let me write them down in a very nice and proper. Okay, so 1 over y minus 2 dy is equal to x dx, integrate both sides. Okay, so now we got to think a little bit, how are we going to integrate 1 over y minus 2 dy, and how are we going to integrate x dx? Okay, so basically this is just a basic rule of integration. So this one is simply a power rule. This is a special power rule because when we bring them up, the power is -1. So on the left hand side, we are going to get a ln. So ln of y minus 2. On the right hand side, it will become x squared plus 2 plus c. X squared over 2 plus c. Oh, by the way, this one should be modulus. So ln of y minus 2 equal to x squared over 2 plus c. But can we leave them as this? The answer is no. Tak boleh tinggal macam ni. Why? Because we are given some particular value. So we need to substitute that value. Okay. So at x equal to 0, y is actually equal to 5. So we can easily substitute the value of y and x and find out what is the value of c. Okay, so ln of 5 minus 2 is equal to 0 square over 2 plus c. So c is actually equal to ln 3. So go back to the last one here and substitute the value of c. So c is actually ln 3. So we are going to get ln of y minus 2 is equal to x squared over 2 plus ln 3. So this is the particular solution. So this is general solution. And this is particular solution. So those are the difference between them. Okay, so now I give you 5 minutes for you to try this question. Find the particular solution for 2 dy dx over dy plus x equal to 4 if y is equal to 2 and x is equal to 3. So I should remind you one thing. This one simply means that you will have a particular solution. Okay, so try to answer this question saya bagi sampai 9.30 lah. I give you 5 minutes. Try to make sure this is separable variable, okay? So you are supposed to learn how to separate the variable. So try and see whether can you separate the variable correctly or not. So ni dia macam based on algebra sikit sebenarnya. Kita nak tengok macam mana kita asingkan dia. Apa yang dah siap boleh bagi tahu dah siap tau. Dan yo siap dah. Laju Dira, semangat Dira seorang je ke siap? Orang lain tak siap lagi. Dah. Okay. Right. Now, okay, let's see. How are we going to do this? Okay, so basically kalau kata kita nak try dulu, benda yang pertama kita buat, kita cuba asingkan dia dulu. Okay, so jadikan ini sebagai subjek dulu. Kita try bawa X pergi sebelah. So kita akan dapat 2 dx over dy equal to 4 minus X. And then, nampak macam boleh asingkan dia kan? Okay, dy hantar pergi sebelah kanan. And then yang ini hantar dia ke kiri. So kita akan dapat 2 over 4 minus X dx equal to dy. Okay, tapi 2 ni tak semestinya duduk kat sini. Kalau nak bawa pergi sebelah kanan pun boleh juga. Boleh je kalau nak buat 1 over 4 minus X dx equal to 1 over 2 dy. So yang ini pun boleh jugalah. So 2 ni tak semestinya duduk kat atas. So nak ambil yang atas boleh, nak ambil yang bawah ni pun boleh. Mana-mana pun boleh. Janji kita asingkan X dengan Y tu. Okay, next. Right, over here, I separate them and then I get 2 over 4 minus X dx equal to dy. And then since we already separate the X and the Y, then we can easily integrate them. So integrate 2 over 4 minus X dx equal to integrate dy. But integrating on the right hand side, be extra careful because the coefficient of X is -1 here. So do make sure to divide by the coefficient of X. So it will become -2 ln of the modulus of 4 minus X equal to Y plus with a C. And then they tell us that when X is equal to 3, Y is equal to 2. So we're going to try to substitute with X equal to 3 and Y equal to 2 in order to get the value of C. So when X is 3, Y is 2, substitute. So we get -2 ln 1 is equal to 2 plus C. And everyone know, right? Ln 1 is actually equal to 0. So C is definitely equal to -2. So go back to your general solution and substitute the value of C. C is -2. Okay, so -2 ln 4 minus X is equal to Y minus 2. And if we write down Y as the subject, then Y is equal to 2 minus 2 ln 4 minus X. So done with this one. Okay, so done separable variable. So now let us move to another method in solving differential equation, which is integrating factor. Okay, so basically for this one, what do you need to do or the difference between them and the separable variable is that for this one, we can write them down as the linear differential equation. So kita boleh tulis dia dalam bentuk linear. So kita tak boleh nak asingkan dia. Not everything can be separate, you know. If you cannot separate them, then do try to write them down in this general form. It's supposed to be dy over dx plus bxy equal to qx. So if you cannot separate them, then do write them down in the general form. But in order to write them down in general form, you got to make sure that the coefficient of dy over dx is definitely 1. There's no other choice. The coefficient of dy over dx need to be 1. So that means if let's say you do have any number in front of the dx, dy over dx. So for example, let's say you have x dy over dx plus perhaps 2y equal to 5. Then what do you need to do is that you need to divide everything by x. So dy over dx plus 2 over xy is equal to 5 over x. So do make sure to divide any number in front of the dy over dx in order to make sure that the coefficient is 1. Okay, so once you know the coefficient of dy over dx is 1, do take note what is px and what is qx. Qx is everything on the right hand side. Px is the term that is multiplied with y. So this is dy. So this is the term that is multiplied with y. And then what do you need to do next is to find something called the integrating factor. So integrating factor, normally we denote them as a V. So V of X, this is actually something called the integrating factor. So Vx is e to the power of integrate px dx. So we should take this px and then we're going to integrate them, and then that is actually the power of e. And then of course you should integrate them and simplify them if it is possible. So do take note that if you have e ln of x, this is actually equal to x. And if you have e to ln x, this is actually equal to x square. So we're going to bring 2 up. So it will become x square. So be extra careful. Once you know what is the integrating factor, the next step is to substitute into this formula. Vxy is equal to integrate Vx qx dx. And this one should be quite easy to integrate. So you should choose which technique that is the most suitable to integrate Vx qx dx. And then after that, you can let y as your subject since you can divide them by Vx. So nak jadikan y sebagai subjek dekat sini, kita akan bahagikan dia dengan Vx. Okay, next. Right, so solve dy over dx plus y equal to ex. Okay, so always compare with the general form, dy over dx plus pxy equal to qx. Okay, so do check. Is the coefficient of dy over dx is 1? Okay, so if you compare over here, the coefficient of dy over dx is already 1, so that is okay. What is the value of px? So over here, the value of px, if you compare them, you should be able to see that px is actually equal to 1. What is the value of qx? Qx is on the right hand side, so this is actually our qx. Okay, so once we compare, we can easily see what is the coefficient of dy over dx, what is px, and what is qx. Next. Okay, so we're going to calculate what is our integrating factor. So Vx is equal to integrate Px dx. So integrate 1, it will become e to the power of x. Okay, so e integrate Px dx. This is Vx. Okay, so integrate Px dx, integrate 1 dx, so it will become e integrate dx, which is simply ex. And then we're going to substitute into the formula. For the formula, we have Vxy equal to integrate Vx qx dx. So you're going to substitute your Vx in. Y will stay as a y. So y ni tak payah ganti apa-apa lah. Stay as y. So Exy equal to Ex times with Ex, and then we're going to integrate them. So simplify them. Ex times with Ex, it will become E2x dx. So integrate e to the power of 2x. So we're going to copy down the exponent together with the power. But then we're going to differentiate or take the coefficient of x, and then we're going to divide them by that. And then ln of the base, ln e. So it will become e to the power of 2x over 2 plus with c. So Exy equal to E2x over 2 plus c. And then of course we can have y as the subject. So it will become 1 over e to the power of x multiply with E2x over 2 plus c. Of course, you can also bring them up as e to the power of negative 2. So that is fine as well. Either one lah, mana-mana je. Tapi saya rasa yang ini mudah lagi. Buat dalam bentuk bahagi je. Okay, so done with this example. So do take note when you read the question, check first, is the coefficient 1? If the coefficient is not 1, do make sure you divide by them first. And then do take note what is px, what is qx. So this is the first step where you want to find out what is px and qx. The second step, you need to know what is your integrating factor. The third step, you're going to substitute into the formula Vxy equal to integrate Vxqx dx. So do make sure if you can simplify them first before you integrate. Okay, next. To solve x dy over dx plus 3y equal to 2. Okay, so now we're going to compare with the general form dy over dx plus bxy equal to qx. Okay, so now we need to ask ourselves, is the coefficient of the question 1? So kita kena tengok lah coefficient untuk dy over dx, adakah dia 1? So the answer is no. The coefficient is not 1. So I need to modify them a little bit. So divide everything by x. So this is dy over dx plus 3 over xy equal to 2 over x. And then we're going to compare and see what is the value of px and what is the value of qx. Okay, so px is whatever that is times with y. So this is y. Px will be 3 over x. And qx will be 2 over x. Okay, so I do know the value of everything, then we can find out the integrating factor. So px, qx, so that is the first step. The second step, we need to know the integrating factor, e to the power of integrate px dx. So we are supposed to integrate 3 over x dx. So integrating 3 over x, it will become 3 ln x. And then since we have a number in front of the ln, we can actually bring them up as the power. So it will become e ln x cubed. And this one can easily be simplified to become x cubed. So that is the second step where we are calculating the integrating factor. The third step, we're going to substitute into the formula Vxy equal to Vxqx dx. Substitute everything in. So we got x cubed y equal to integrate x cubed 2 over x dx. So do make sure to simplify the right hand side first before we integrate them. Okay, so simplify, it will become 2 integrate x squared dx. So integrating x squared, it will simply become x cubed over 3. Okay, and then you got to let your y as the subject. So y is equal to 1 over x cubed, 2 over 3 x cubed plus c. Or you can actually bring 1 over x cubed up lah. You can bring x cubed up. So x to the power of negative 3. Yang tu pun boleh juga lah. Okay, so you got 2 answer. You can choose either one. Mana-mana pun boleh lah. Dia setara je. Okay, next. Oh, next lesson already. Okay, so for the next lesson, we're going to learn how to apply the method of solving first order differential equation into 4 model, which is the population growth, radioactive decay, Newton law of cooling, as well as the electric circuit. So ini untuk hari apa? Selasa. So nanti hari Selasa kita akan tengok model-model ni, and then we're going to see how are we going to solve them. Macam mana nak solve lah. Okay, so I think that's all for today. So well done everyone. Okay, so kita jumpa hari Selasa nanti. Goodbye. Good night. Have a nice sleep. Goodbye.